Hey guys, so we are starting limit, I call it limit.1. This is our chapter on limits, and this means we are starting the calculus section of our class. So if you remember what feels like an eternity ago at the very beginning of our class, I said we started off with reviewing Algebra 2, we really moved on to pre-cal material, which was like our trigonometry and our vectors, and I said we'd finish up with actual calculus. And so my goal for these next 3 units is to give you an overview of what you would see in a Calculus 1 course. We won't go as deep, of course, as a Calc 1 course because we've got like a month left, but man, it'll give you a really good overview. That way, if you take either AP Calculus with me next year, or maybe you take Calc 1 in college, hopefully a lot of it's going to look familiar after going through this. And hopefully, you're going to look at all this and think, wow, this is actually pretty easy, especially compared to some of the stuff we've done. So yeah, let's go ahead and dive in. All right, so problem numbers, well, all of these say LIM. Now, LIM stands for limit. Of course, in math, we're not going to use more than 3 letters for a word, so we just shorten the word limit to LIM. And it says the limit as x, and then we see this arrow. That arrow means approaches. So x approaches -1. Now, we've seen this right here before. We've used that notation before. That's nothing new. I specifically use this notation with you, knowing that we'd get to this lesson, okay? So let's see here. Limit as x approaches -1. Well, let's find x is -1. Here's -1. That line right there, that kind of got off on a little bit. Oh, you know what? Let's try that again. Cheat just a little bit. There we go. Oh, look at that perfect line. There we go. There's the line, x equals 1. Now, approaches -1 means that as I approach it from the left and from the right, it's saying, what y value am I approaching as I approach the x value of -1 from the left and from the right? Well, now on a lot of problems, all that means I need to do is just plug the value in. So if I just plug in -1 in for my value, so I'll get the cube root of 2 times -1, and then that is a, let's see, -5 minus 5. What will I get? Well, 2 times -1 is -2 minus 5. So for number 1, I'm going to end up with the cube root of -7, okay? Which, if I plug it in, is really close to -2, but not quite. So I see really close to a y value of -2, but just slightly above it. So that right there is what I end up with. Well, what about this one over here? It says, again, I'm approaching a value, an x value of -1. -1 right here. There's -1. Okay. All right. So as I approach -1 from the left and from the right. So as I approach it from the left and as I approach it from the right, what am I approaching? It really looks like I'm approaching 6. All right. Looks like the y value of 6. How do I know for sure? Well, I'm just going to plug -1 into my equation. Okay. So let's plug it in. So my equation is this: so -1 cubed. Actually, no, let's be a little smarter about this. Let's just plug it into my calculator. All right. Yeah. Second quick. Here we go. -1 to the 3rd power plus -1 squared plus 4. And look at there. It is, in fact, 6. Okay? So that's what you do on the first 4. Right? And if I zoom out a little bit, the answers they gave me, there you go, same thing. For number one, they put the negative on the outside, and that's okay. I put the negative on the inside. They didn't. Right? So try the next two. I'll give you, pull those up, and I'll give you the answers in just a second. All right, so the answers to 3 and 4 are negative 1/15 and 3. Okay, just plug in the numbers in. Well, what if it looks like these numbers 5 and 6? Well, again, we're just going to plug the number in. So, annotate. Pull up my calculator. Let's plug the number in. So I have a fraction, so alpha y equals. The top is x, so I'm going to plug 1 in. And the bottom, I'm saying 1 squared minus 6 times 1 and plus 9. And that gives me 1/4. So number 5 is 1/4. For number 6, if I plug 2 in for x, what do I get? Well, I just get 2. All right, there you go, 5 and 6. All right, what about number 7 and 8, which both end up having to be secant for some reason? All right, well, for these, we're going to think about our unit circle. Right? So let's look at number 7. So I'll plug it in. So negative secant of 2 pi. Remember that secant is just, and I'm sorry, I'm doing this on my paper and realized I didn't write it out. So there we go. There's my video. Negative secant of 2 pi. Well, secant is just the reciprocal of sine, so I could say this is negative 1 over sine. Sorry. Cosine of 2 pi. What is cosine of 2 pi? Well, cosine of 2 pi is just 1. Negative 1 over 1 is negative 1. The same thing for the other. So let's see if I get my answer. I get that. So for number 8, it was probably 2 over the square root of 3, because you do the reciprocal, and then they just multiply top and bottom by square root of 3. All right, moving on. What about number 9? I'm going to make this one a little bigger so we can really see what's going on. All right, there we go. Now, I told you that a limit said approach 1. So here's 1. And it's approaching from the left and from the right. So what am I doing as I approach from the right and from the left? Okay. Well, number 9, as I approach from the left and from the right, is approaching 2 different values. From the left, it's approaching a y value of 0. From the right, it's approaching a y value of negative 1. Whenever it approaches 2 different values, from the left and from the right, we say the limit does not exist. Except that that's 4 words, and we don't like writing any words, so we put the does not exist. Okay, so the limit does not exist, which we of course just write D and E because I only write 3 letters. That's the most letters that I'm going to write. So there you go. D and E, or the limit does not exist if you feel like writing 4 words out. All right, well, let's make that smaller so I can look at the others. Well, let's look at these. Number 10. This is approach 0. Well, as I approach 0 from the left and from the right, I'm approaching the same number. What number am I approaching? Again, what y value? I should specify what y value. I'm approaching the y value of 3. So 3 is my answer there. For number 11, as I approach from the left, I'm approaching a y value of -1. From the right, I'm approaching a y value of +1. Now it's open circles, which actually doesn't matter. It doesn't really matter if there's an open circle there or not. Limits don't care what's happening at the value. They just care about what the function's approaching as I get closer and closer to that value. Well, here they're approaching two different values. So what's my answer? D in E does not exist. Now, it does not exist. And yes, that is the line from Mean Girls. Help that. All right, moving on. Number 12. Let's see, where's my annotate? So we're approaching -1, which is right here. And -1 on this side again, right here. So where am I approaching from? The left and from the right? Well, here it appears that I'm approaching a y value of +1. Here it appears that I'm approaching a y value of -1. So if I do that, look at our answers, 1 and -1. There we go. 14 and 15, I'll let you try those real quick. I'll get the answers. All right, the answers are 0 and 1. All right, oh, 16, try it. It is 6. Okay, is that here? What value is 6? All right, well, then we go on to number 17, which looks just like a problem we've done already. So let's see, 17, let's just plug in. In the top, I get negative, alpha y equals -1 plus 1 over negative, parentheses, -1 squared plus 4 times -1 plus 3. All right, enter. And I get an error. It says divide by 0. So now we're actually going to have to do a little bit of work. And this is going to be the most common type of limit I see, is this right here, this little fraction. So let me write it out on my paper, and then I'll switch the video to full screen so you can see what I'm doing. So this is what we have. Now, if I plug -1 in, what I really end up with is 0 over 0. I get 0 at the bottom, 0 at the top. 0 over 0 is called indeterminate form. You would think for mathematicians who hate writing words, they wouldn't use words so long, but that's what we call this, indeterminate form. Indeterminate form basically means you haven't done enough work, keep going. Okay, 0 over 0. Now, this is an important time to say, if my limit is 0 over 0, I need to do something else, which is what we're going to talk about. However, if my limit is 0 over something else, say 3, well, that just means 0. If I end up with some number over 0 like that, that means does not exist. Okay, so indeterminate form has to be 0 over 0. If I get just 1 0 on top or just a 0 on the bottom, then I can tell you what the limit is. It's 0 or does not exist. 0 over 0, that's indeterminate. I need to do some more work. Well, if I have a fraction like this, what they want me to do is factor. Well, the top is x plus 1. Can't really factor x plus 1. It is what it is. But the bottom, I can factor the bottom. It's x. Next, we'll see, 3. 3 is 3 and 1, and they both need to be positive. Well, notice what happens. the x plus 1s cancel out, which if you remember, tells me that I have a hole in my graph at 0, 0. Okay, that's what that means. Things cancel out, I get 0, 0. I have a hole in my graph. Well, if I cancel those out, I now have the limit as x approaches 1 of what's on top. Well, it canceled out, so I'm left with just a 1 on top. Whenever something cancels out, still 1. And in the bottom, I'm left with x plus 3. But now I can take that 1 and plug it in. And I get 1 over 1 plus 3, which is 1 over 4. So 1 over 4 is what I get for 17. So when you have a fraction like this, you try to plug the number in, but if you get 0 over 0, factor, cancel stuff out, then plug it in, and you should get a number. Or you should get one of these two cases. You still get an answer. Okay? So let's go back over. Try number 17 real quick. Pause the video, and then I'll show you the answer. All right, so the answer 18, is 1. And it tells me that the answer 17 is 1/2. Oh, and it's because I wrote the problem down right and just messed up. So sorry. Let me go back to my paper real quick. Point out my mistake. Right here, I clearly wrote -1. And then down here, forgot to keep the negative. So if I would have kept the negative there, I would have plugged in -1. That would be a negative. And -1 plus 3 is not 4, it's 2. There we go. Sorry about that. Oh, there we go. 1/2 and 1 for 18. All right, move on. 2 more of these. Actually, there might be. Yeah, why not? So go ahead and try those 4. I'm going to pause the video. Okay. All right. The answers are 1, 3, -6, -1. 21 is at the top. That's a difference of squares, so you factor that into x plus 3, x minus 3. For 22, the top is, you factor x out, but remember there's a negative out front. So if you end up with +1, you probably forgot about that negative out front. Same thing with number 19. All right, and I think there's 2 more problems left. Yep. All right, so you can pause the video here and try these 2. And the answers are 1/4 and 2. Okay, so you can go to factor, cancel stuff out, plug in, and get those. If you have any questions on those, please send me a remind text, and then I will do a Zoom session with you individually and help you out on those. But hopefully you're looking at those like, oh, yep, that's pretty easy. Which is awesome. We'll see you next time at Limit